Hello everybody. In this video I want to talk a little bit about the different states of matter. I actually don't even really like the language that the reading uses where they call them states of matter. I actually prefer to call them phases. So you might see people call them states of matter or phases of matter, depending on which book you read. And we're actually pretty already familiar with these. So we have solids. A solid has a fixed volume, it has a fixed density, and it has a fixed shape, right? If I take a solid cube of something and I stick it in a different container, it's not going to change its shape. It's just going to still be a cube. The solids are going to exert pressure on their environment. And what's going to happen is we're going to have gravity. Gravity is going to be pushing down on the solid, and the force of that is going to be spread over the area that is in contact with whatever it's sitting on, and that's going to be the pressure. So it's going to force a downward pressure on whatever it's sitting on. And we can see that mathematically here, where the pressure it exerts is equal to the force of gravity that's pushing down on it divided by the area that is touching a surface. Next we have liquids. Liquids do have a fixed volume, okay, and they have a fixed density, all right. And they exert pressure due to gravity as well, but they're going to exert that pressure outwardly all the way around it. Wherever it comes in contact with the container, but not necessarily on the top where the container is open. Unlike solids, though, liquids are going to change their shape to fit their container. So when I pour this liquid into this container, it takes the shape of this container. If I pour it into a different container, it's going to take the shape of that container. And then finally, we have gases. So you can picture gases like this could be like a little tank. There is gas inside of it, and those little gas molecules are moving around really fast in there, and they are striking the walls of the container at every point. So everywhere all the way around this container, that gas is exerting pressure. Okay, even at the top here, it's going to be pushing up at the top of the container. So gases, they have no fixed volume or density. They're just going to expand to fit the container. Okay, if I put this into a larger container, it's just going to lower its pressure and expand out and fill that entire container. Like we talked about, they exert pressure equally on the walls of the container. And yes, they expand to fill their container. So, how do we go between our phases and what do we call them? Okay, so moving from a solid to a liquid, this is something we're familiar with. This is called melting. Moving from a liquid to a solid, this is known as freezing. Moving from a liquid to a gas, this is what is known as evaporation. And there's actually another phenomenon that's a little different from just regular evaporation called boiling. Moving from a gas to a liquid, we call that condensation. You might get that on the outside of a cold glass. On a hot summer day, you'll see water condensing on the outside of the glass. And then we have this little bit more exotic behavior that we don't always see, but actually is probably occurring more than you're really aware of. We have something that moves directly from a gas to a solid. This is called deposition. An example of this would be like when frost forms on a window during when it's really, really cold outside. Sometimes it never even really becomes a liquid, but instead goes straight from being water vapor in the air to frost, solid frost on a window. And then we have from a solid to a gas. This is called sublimation. One example of sublimation would be like mothballs, which were a thing that people used to put with their clothing to protect it from bugs and stuff. It was a solid material called naphthalene, and it would just start turning into a gas that moths and other bugs did not like and therefore would get away from. Now we have kind of a big idea here where this is going to explain the difference between boiling and evaporation. Imagine that I have something like a puddle or maybe like a small pond or something like that. What is happening is there is liquid water in the pond and there is water vapor in the air above it. And all the time, water vapor from the air is condensing and going down into the pond, and water from the pond is evaporating and going up to the air. So I'm going to call the water vapor. I'm going to show you the way that we write this would be like H2O with a G next to it to indicate that it is a gas. Okay, so here I have a chemical formula that also says that I have 2 hydrogens and 1 oxygen. We saw that that was the molecule that makes water. And over here I have H2O, and in these little brackets here I put a scripted L to indicate that it is a liquid. And these back and forth arrows here are showing what's known as a dynamic equilibrium. So as I said, water vapor is turning to liquid water and liquid water is turning to water vapor. The question is how much is in the vapor form versus how much is in the liquid form. And the answer to that has to do with the rate that the gas turns into a liquid and the rate that the liquid is turning into a gas, which is related to the temperature, which is kind of intuitive, right? On a hot day, a little puddle is going to move up into the vapor phase and it's going to evaporate, it's going to disappear. Whereas if you see like hot air being fed into an air-conditioned area, you can see water vapor that can actually condense down and even form a puddle inside, okay? Or just make everything kind of damp. So, as temperature goes up, the amount of water in the gas phase is going to go up. The amount of water in the liquid phase is going to go down. Okay? And then conversely, if the temperature went down, the amount of water in the gas phase is going to go down. The amount of liquid water would go up. Okay? There will be a point at which there could be the rate that things are moving to the liquid is going to be equal to the rate that things are moving to the gas phase. And then this is stable. There's still transfer back and forth, but the same amount is going to be moving into the gas phase as will come down into the liquid phase. And that is the point that will ultimately be reached if we held the temperature constant. Now, there is a pressure that the water is exerting on the atmosphere called the vapor pressure. The vapor pressure also rises as the temperature rises. Okay? And at some point, that vapor pressure could become greater than or equal to the atmospheric pressure the pressure that's pushing down on the water from the air above it. And when that happens, we see boiling. This is when we start seeing those rapid evolution of bubbles and stuff like that, because there is a force, the excess pressure that the vapor pressure has, that allows it to push up and out of the container.